Let's get started. Russell Mosley.
Okay, thank you. And thanks for coming to my presentation. So my presentation is called Robust Defense for the Rest of Us. And it's a response to the DEF CON 25 CFP and the generalization that small businesses are terrible at information security. So everybody knows that DEF CON is a hacking conference, right? You may not know that they have a defensive track listed on their CFP that you can submit presentations to. I was reading their CFP, and this is the description for it. How do hackers defend their networks, servers, and applications in a world where only the largest enterprises can afford a robust defense? What can you do to have a chance at surviving modern class attacks? And that caught my attention. Only the largest enterprises can afford a robust defense. I hear this a lot, and I have to disagree. Size and budget don't equal better information security. Having a robust defensive posture isn't about what you can afford. Having a robust defense is about what your organization prioritizes and chooses to do, regardless of the size. It's your policies, processes, and procedures that determine your success, not how much you spend. In fact, I think that small organizations can be more effective at information security than large organizations if they want to be, because they have some advantages over large organizations. Small organizations can configure more granular policies because we only have to allow access to services and sites that are needed for our business requirements, and those business requirements are much narrower than large organizations. So it's easier to define business requirements and implement things like least privilege in a smaller environment. We also have less static to sift through. You know, we have fewer users. We have fewer amounts of log data that we have to analyze. We also can do quicker vulnerability management mitigation than large organizations because we have a much smaller environment. And as a small organization, we have better knowledge of our environment than many large organizations do because one close-knit team does all of IT operations and security. So in this presentation, I'm going to present an argument that small organizations can afford a robust defense and demonstrate with an example case study of a small business security program. It's the security program that my team and I have built over the last 15 years or so. And not only do we have to meet our standards, but we have to meet FISMA, which is the NIST Special Publication 853, Rev 4 at the moderate level for a federal government information system that we operate. But we also have to pass annual SSA 16 audits, and we do CMMI Level 3 for development. So we have a lot of process that we have to have in place. And I hope that this case study can also serve as a framework for other small businesses to establish their own security program. Well, briefly about me, this is my Twitter homepage. I chose the name Smoke'em for Twitter because I mostly just listen on Twitter. I don't tweet much, and I like to do things like that with cars. So that's what I came up with. Anyway, I have my claim to fame in InfoSec on this slide. You see there is my pinned tweet, right? I was named the unofficial MVP of BSides Chicago for doing back-to-back presentations last weekend. That was pretty awesome because the presenter didn't show, and I had 2 different presentations ready to go. Anyway, that's me. I have 17 years of experience in IT. Started out doing systems administration, then got into InfoSec, and now I do like enterprise defense. I'm responsible for IT operations and for our compliance and for meeting all those requirements I was describing. Additionally, I'm a BSides Charm organizer. I'm on the organizers team, and I want to show you, I have my BSides Charm keychain floaties with me today. So if anyone wants to come up to me and find me, ask me anything about the presentation, I'm probably the only guy here with keychain floaties hanging off my badge. So back on topic, having a robust defense isn't about how many products you buy or how much money you spend. It's about your security program and all the things that you actually do. I'm here to dispel the myth that small organizations have crappy security and that the size of the organization determines how secure it is. Security has to be a priority for your organization, no matter the size. You can't rely on your vendors or hope to avoid incidents. Large organizations have silos, right? We've all heard this before. In the slide here, it's purchasing, marketing, sales, and operations. Well, there are silos for IT. And at really large organizations, there are even silos for information security today, right? You have security engineering, which usually is a different department, different people than your SOC analysts. And those people are also different from the team you would send out to do incident response. And they're all different from the people who do IT operations. So they can't have as much knowledge of your operations as you can contain into a small team in a smaller organization. Large companies also tend to outsource to managed security vendors, right? And these companies specialize in monitoring all your log data and trying to identify like what's a real incident that you have to do something about versus just noise. But they're even another step further removed from your actual IT operations and less knowledgeable of your environment. Additionally, many InfoSec practitioners at large orgs tend to become jaded and feel like all of their efforts are worthless. This is another benefit of a smaller organization. You're more likely to have a larger voice and be able to reach the decision makers and policy makers at a small organization. And there are going to be less layers of red tape to get through to make changes and get things done. So what does it take to have a robust defense? Well, I think you always have to have management buy-in and commitment. You know, it has to be top down. Your management has to be committed to information security. Executives need to understand their roles and responsibilities, and they shouldn't be asking for exceptions to the rules. They should set the example and make sure InfoSec is considered and consulted in business decisions. And they need to be committed to investing in resources into information security. Additionally, to have a robust defense, you have to have a minimum set of policies and procedures. All large organizations tend to have these, and it's not that hard for small organizations to set these up either. I'm talking about things like an information security policy, an information risk management policy, an acceptable use policy, which is actually signed by read and signed by users before they get access to your environment that says what they can and can't do in your environment. And those should also be reviewed and signed on an annual basis. You also have to have patching procedures, mature process to get all your vendor patches applied as quickly as possible. You have to have incident response procedures. Even if your incident response procedure is call this company that we've set up a relationship with and they're going to come in and do response. You need to think about that kind of stuff in advance. You also need to have baselining procedures for deploying systems. And you should ideally have a ticketing system with an authorization and approval process. To have a robust defense, you also need to try to implement the basic principles of InfoSec. And I'm talking about default deny, least privilege, and layered defenses. We've all heard about these. And I argue that they can be done more easily at a small organization than at a really large organization that might have been around for longer than the internet, right? And when they first put in their first firewalls and email, everything was wide open. Well, now you have to go back and change all that. It's a lot easier at a smaller organization. You also have to be flexible and adaptable to emerging threats. You need to be able to deploy patches quickly. And with a smaller environment, I think that it's easier to do that than at a large organization. And lastly, you have to leverage your home field advantage, right? People say in information security that the attackers only have to be right once and the defenders always have to be right. Well, I don't think that's entirely accurate because you have to take into consideration home field advantage. Your knowledge of your environment gives you a huge advantage over your adversaries when it comes to InfoSec, right? So it's critical that you have deep knowledge of your environment in your people who are doing your security and your incident response, right? So how well you can concentrate that knowledge into those people, I argue, will make them more effective. In a smaller organization, that smaller team is going to know a lot more about all of your environment than in a large siloed environment. So for our case study, the company that I work for is a small business in the DC area. We have about 40 employees, right? Not very big. You wouldn't think of a company that size generally as having a really mature security program. And that's, what I'm here to talk about. So we have about 40 employees. We are a technology company. We're not like a construction company or something. We are a technology company, so we have a lot more resources than maybe other small companies do. My team is a staff of 6 people. It might sound like a lot for a company with only 40, but again, we have to maintain a lot of compliance requirements for SSA 16, for our FSMA moderate ATO, for our federal system that we run, and for CMMI level 3 for development. A couple other interesting things. We mostly operate on-prem systems. So we have about 250 servers at 2 locations today. And we don't use many cloud services. We're not using Office 365. We're not using Google Docs. We're not using Dropbox or any of that. We tend to run everything on-prem and try to retain the knowledge of the environment and configure them as locked down as we can. So I'm going to highlight our implemented security controls at various levels. And I apologize I can't take the time to describe all of the tools and things that we have implemented in advance because of the 25-minute time slot. But I tried to get everything I want to mention on the slides. So if there are any tools like you haven't heard of, you could go back and look at the slides, or you could come find me. Again, I'm probably the only guy here with BSides Charm floaty keychains, the red and blue. I'd be glad to talk to anyone about anything that we're doing after the presentation. So starting with perimeter protection, we manage our own infrastructure. our routers, switches, VLANs, everything in our data center. And we have a real data center. It's a raised floor, 3,500 square foot data center with crack units, UPS, everything, because we've been doing this since the 80s. It used to be full of mainframes. Now we have like 8 to 10 racks of equipment, but it actually is a data center. It's not a closet, okay? And we try to do everything ourselves with regard to hardware. So, we install all the servers. We install all the network gear. When a drive fails, they ship us the drive, we put it in. We try to retain that knowledge in our small group of people. So some of the layers we have implemented, we're doing RFC 1918 and LAN protocol filtering out at the routers, just stopping all that stuff out there. And everything is behind a firewall cluster. We don't have anything on the perimeter exposed. Everything is behind a firewall cluster. We've implemented geoprotection. So geoprotection, if you don't know, you can block IP addresses by what country they've been assigned to. So we actually block everything from outside the United States from coming into our environment. Not a lot of large organizations can do that. Not a lot of small organizations can do that. Well, we can because of our business requirements. This is what I was talking about with the basic principles of InfoSec, default deny, least privilege. We don't need to get there. They don't need to get here, so we just don't allow it. Now, if somebody wants to attack us, sure, there are proxies and other ways that they can get past that. But it's just a simple method to knock off a whole lot of noise that we'd otherwise have to deal with. Similarly, we've implemented the SANS Storm Center block list, which is something that's been around for at least 15 years. It's just a simple, crowdsourced list of the top, I think it's 20 or 50 attackers that they see every day from everyone who submits information to them. And you can download the list for free off their website. There are scripts you can download to throw it into IP tables, and actually a lot of enterprise products, including the one that we use, have a checkbox. Block everything that's on the SANS Storm Center block list. So we've implemented that. We use Cloudflare for public DNS and their WAF for our public websites as another layer of defense for those public systems. And we run our own on-prem GPS NTP time servers. They're actually a fun thing to implement, and then we don't have to reach out on the internet for NTP to pull down time data. For network segmentation, I think this is something that's also easier done in a small environment, right? We have a dedicated PC LAN, internal, we have a dedicated internal servers LAN, and we have multiple customer DMZs, physically segmented. So no traffic can go from one to another without an explicit rule in the firewall. This isn't something that's really complex to do, but I think it's a lot harder in a really large environment than it is in a small environment. We also have an isolated guest net. And that's the only way you can get Wi-Fi in our facilities is on our guest net. And this is completely isolated. So we have separate cabling throughout the building to the different APs, and they go to their own Comcast cable modem. It's something that's not very complex, but I talk to other people at other companies, and they're like, who does that? Nobody does that. It's like, well, we do. Why not? It's simple. And if people want to go out to social media, Facebook, Twitter, whatever, we don't allow any of that on our internal network because it's not core to our business. But we encourage them to bring their mobile devices, get on the Wi-Fi, and do it from there. We also don't use DHCP. We don't have that many nodes. We can statically assign all the IP addresses and run ARPWatch, which is a free tool that alerts us when there's a new MAC address or IP change on the network. For default deny and defense in depth, a few items here. We don't have any default outbound allow firewall rule. We don't have any automatic NAT, so any new object that shows up on our network, it can't pass any traffic in or out until we put in a firewall rule. And we have change control processes where they have to be approved by myself or one other person who are the authorized approvers, and we approve each other, so nobody can just make a change and allow something new to pass traffic. We also do TLD blocking, and people think I'm crazy when I tell them that we do this. But TLDs, these are your top-level domains, .com, .net, .org, .gov, right? So for our business, we did some analysis of logs, and we determined the only ones that we actually need for anything that our business does, it's like 8 TLDs. And nowadays there's like .car, like .pizza, there's all kinds of crazy stuff, right? And in our analysis of a lot of the phishing emails that we get, usually they're like .io or .ru or other places where we simply don't need to get to. So this is simple. Cut it off at the web proxy. You can't get there. We also do file type filtering to exclude executables on our web proxy and on our email filtering. And we have many layers of email defense in depth because, again, we run our own on-prem installation of Exchange. So quickly, the layers that we use Spamhaus. They have a DNS block list. Our firewall product has a blade that does email protection that takes out those links, removes things that look like malicious files, etc. It passes all the email then into another email protection gateway that's from another security company, a different company, that does the same types of thing. And then finally, it gets internal to our Exchange environment. We've also implemented SPF and DMARC, and we do attachment monitoring for DLP. For user-level protections, we lock down all of our PCs like you would expect at any company with a really mature IT department, right? We have a mature group policy that, you can't be an administrator, you can't change a lot of stuff, you can't install programs. We've also implemented multi-factor authentication, so everyone has their username and password, and they also have a token. Used to be a hard token, now we use the mobile app tokens because everyone brings their phone to work, and we don't have to give them as many temporary codes. But we've implemented multi-factor authentication. And for mobile device restrictions, a lot of companies have tried to figure out how to deal with this, and you can block USB ports via GPO. But something that we've done in addition is we've provided everyone with power strips on their desks that have the USB ports now. You can go buy these, anywhere. They have 2 or 4. So we tell people, hey, bring in your phone, but instead of plugging it into the computer, plug it in right there. We provide it to you, and that avoids a lot of people plugging stuff in and us having to go track it down, tell them don't do that, etc. So for content and malware filtering, in addition to web proxying, we also use DNS filtering. With what used to be OpenDNS, I think they're now called Cisco Umbrella. There's also Google's DNS. There are several of these companies out there, right? And most of them let you use their service for free, and they will block known malicious websites, and they will block access to adult websites, based on the DNS. But if you pay for a subscription, you can also do category blocking, just like you can with a web proxy tool, to block access to wide categories of things that might be offensive material, things you don't want to show up on your network. So it's just another layer. We use the web proxy and we use the DNS filtering. Also, our firewalls block shadow IT services. So, like I said, we don't let people get out to Dropbox or Facebook or Twitter, things like that from our internal network because it's not core to our business. The way we do that is with the firewalls. They block access. They can identify all kinds of different shadow IT services, and we just block that stuff. Everybody knows it's part of the policies. We do a lot of trainings, but that's how we actually implement it. We're also using Sysmon and Splunk to automate alerting on anomalous activities on our endpoints. And of course, we have a mature information security awareness program that involves annual trainings and user recertification. For patching, we have a mature monthly process to make sure that all of our vendor patches are applied. If you have to meet compliance requirements for FISMA or for PCI, they all define like a time frame, like 30, 60, 90 days. You have to apply major vendor patches, right? So we have a pretty mature process to make sure it gets done. Everything's tracked and it's automated. It's audited by our SSA 16 auditors every year. For network monitoring, we have implementations of Snort IDS, Bro IDS, our firewalls IPS product. And for all of these, I'm not talking about like installing it in default settings and running it, right? There's a lot of care and feeding involved in these tools, and you have to get new signatures, you have to customize them for your environment. This is all stuff that we're able to do. We also run HTTPS inspection on our firewall and on our web proxy. If you're not doing HTTPS inspection, you can't look for those categories, look for certain types of traffic if it's encrypted. So you have to implement HTTPS inspection. This is another thing that we're able to do. And we also use Shadow. Has anyone heard of Shadow? Quick show of hands. No one's heard of Shadow? So Shadow is a tool that was developed by the US Navy in the 1990s, and it's basically a set of Perl scripts that's like a wrapper for TCP dump. And with Shadow, you set up filters, and it records all the network traffic that you feed to it, and it breaks it down into TCP dump files by the hour. So we run Shadow, and we run it on our perimeter, and we record all traffic that goes between us and the internet, and we keep 90 days worth of internet traffic on disk in our data center, so that when we see something that looks like they might have clicked on a link that took them to a phishing site or a site that we know could be infected, we simply go back, pull the file from the hour, look at the traffic, and start our analysis from it. It's a great tool. It's free. It's just another thing that you can do. For system monitoring, we run Splunk, and we send all of our event logs from all of our network devices, all of our servers, even all of our PCs go into Splunk, and we have a lot of searches that generate alerts for us. I'm going to talk more about in a moment. We also run What's Up, which is an availability monitoring tool and a performance monitoring tool, as well as Veeam1 for our VMware environment. So daily ticket reviews. So we have an automated process that generates tickets for us and alerts. And we have a couple of different ways that we do this. So, like I said, all of the logs get sent into Splunk, right? On Splunk, we have 1 to 5 minute searches that identify real high severity issues. things like a problem with a router or a signature for a ransomware, and those will send us text messages to every one of my team's phones. And then we have other searches that we've customized that generate tickets for us every day to look at things like VPN logins, root and admin logins, print jobs, email attachments, and every swipe of building keys in our environment, right? A lot of big companies look at this stuff too, but I think in general, they're automating looking for things that they think are abnormal, or like you only look at the fails, right, not the successes. Well, this goes to my argument. In a small environment, we look at the successes and the fails every day on all of those things. We have to review tickets that show it. So we know what our normal operations look like better than a large organization would that's only getting alerts on fails or things that they defined, maybe months or years ago. We know what it looks like every day. For configuration management, we're running Ansible. For configuration changes to all of our Linux environment, we use VMware templates to deploy servers into our VMware environment. We have PC images to make sure that all the PCs are deployed the same way. And all the change control is monitored in our ticketing system. We also do our own vulnerability scanning. We run automated weekly scans with Nessus. We do manual scans pre-deployment with Nessus and Burp for our development staff. We use some other tools as well, but these are the primary. And we also do automated daily web scans by Securi. Securi is a vendor where it's like $25 a month. They'll scan 10 websites for you. So we have public sites, and in addition to all the monitoring we're doing, we have them hit them every day, and they look for indicators of compromise or that we're behind on a version of WordPress, that kind of thing you want to know about and get fixed. So it's just another inexpensive way of monitoring your environment. For incident response, we have pretty mature IR policies and procedures, and we do annual IR team role-based training with all my staff. We also have monthly staff meetings, and during our staff meetings, we do postmortems for any incidents that came up that month. We have an implementation of Cuckoo Sandbox in our environment, which is a great open source tool that you can feed files, you can feed URLs that you think might be suspicious, and it'll do a lot of analysis and give you a score and give you a lot of ways that you can go do further investigation. We also run, like I said, Bro and manual traffic dump analysis from the shadow logs. We also have experience running Autopsy and some other open source forensic tools for disks. So that's a very brief overview of the security program that we've implemented. One thing I didn't mention earlier, I said the team is 6 people, right? We have one dedicated InfoSec person, one person that's their title that doesn't have any other roles and responsibilities like systems administration, database administration. We're able to do all of the things that I talked about with 6 people and one dedicated. So in conclusion, the statement that only the largest enterprises can afford a robust defense, I think is false. Not all small businesses are hopeless when it comes to information security. Small organizations can afford a robust defense, and for the reasons that I described, they can be more effective in some areas than larger organizations. So I wanted to quickly say thank you to Chris Ang, who was my mentor for the presentation, and if there's any time, take any questions.
What's your approach for remote access, for remote workers, like working from home, and VPN access? Do you allow those in the network, or you are not required to have that?
A good question. We do have a VPN. It's not available to everyone. So one of the VPs actually has to sign off for VPN access for someone. So if you're a developer for us, you don't automatically get VPN access. It tends to be worked out when people are hired, how much remote work they're going to do versus on-site. And if there's a business need, we do give them VPN. It's a full IPsec VPN product that we deploy.
Remote access, like remote control for desktops, something like logging, something like that. Do you allow that, or you don't allow that?
If they have VPN access, then the only thing that they can do through the VPN tunnel is Windows Remote Desktop. That's actually something else I should have probably mentioned in the slides. But the people that we have given VPN access, they don't just have like wide open. It's configured on the firewall, so the only thing they can do is RDP to the internal network to their corporate PC. That's it. So whatever rights that we've given them from their corporate PC, then they can get out to that once they get in. Thanks.
Thank you very much.